This is number 30 from chapter 6, section 2 in the back of your book. It reads, the reaction SO3 in the gas form plus H2 in the liquid form react to yield H2SO4 in the aqueous phase. This is the last step in the commercial production of sulfuric acid. The enthalpy change for this reaction is negative 227 kilojoules. In designing a sulfuric acid plant, is it necessary to provide for heating or cooling of the reaction mixture? So basically this is going to ask us when we're creating this sulfuric acid, do we need to cool the plant or heat the plant? In order to do that, we need to figure out whether or not this reaction is releasing heat or absorbing heat. So if the reaction is absorbing heat from the surroundings, meaning it's endothermic, we're going to have to heat the plant or else it's going to get infinitely cold. If this reaction is releasing heat into the surroundings, exothermic, we're going to have to cool this plant in order to keep it from becoming so hot that it's unworkable. The first thing I want to draw your attention to is this value for the enthalpy change. It has a negative sign. Negative sign on the enthalpy change indicates the direction of movement of that energy. This 227 kilojoules, where is it moving? This negative sign is telling me. And if you remember, enthalpy change is always from the perspective of the system. So if from the perspective of the system, that's a negative value on the enthalpy change, that means that the system is losing 227 kilojoules into the surroundings. From the system into the surroundings. So in this question right here, in this situation, the surroundings, the same thing as saying the plant, or plant, one plant. So if the system is generating heat and is releasing that heat into the plant is going to be very hot. And so we will have to provide for the cooling of the reaction mixture, because 227 kilojoules of heat is being released into the plant by this reaction.